This tutorial is an introduction to the use of GeoGebra, particularly in relation to applying sliders to polynomials. So to put in an equation, we can just go to the input line and type in anything we want. So I'm going to put in, say, 2x cubed, so it's going to be cubic, plus say 4x squared minus 3x plus 1. Notice I didn't put y equals. You don't have to, and it automatically comes up with function x. Okay, so obviously you can just type in any function and it will graph it for you, but that's not going to be very powerful. It would be much better in the end if we could actually change each of those polynomial coefficients to be a variable or a constant. So let's come in up here and make this a times by instead, and this be b times by c times by, and just plus d, and we'll see what that does. So do we want to create sliders? Yes, we do. Alright, so now what we can do is get access to a whole range of different polynomials by simply just changing what the coefficients of each of those terms are. So that's quite useful for investigations. Now, what are the sorts of things we might want to look at, or students might want to look at? So if you're under this option here, A, you can find turning points. So you can click on your graph, that shows you the turning points. Mind you, it doesn't actually really show you the value except for looking across here, but what you can do is if you select these points and right click and go into the properties, there's an option here that says name and value. So, and then you can actually exactly see what they are, and you can move these around if you wish. So that's any maximum and minimum values. If you wanted to, you could also find out any roots of the equation. So just typing on here, and we've got those roots. And likewise, if you actually want to see the values themselves on the points, select them, right click, and we have it there, name and value. Alright, so we've got all of that occurring, but then the only problem is that once our points come off the x-axis, our root points, then it doesn't show up as having a root. But if we are allowing complex roots, then actually those points should have a value. So like this point here, different points should have value. So the way we do that is to use another command, which is complex roots. So for starters, I'll just go and get rid of each of these points here so we can see what's actually going on. Alright, so all the points have gone from there. Now one simple command is going to do this for you. Complex root. So complex root, and then the polynomial is f, hit enter, and it shows you the complex roots for this. So it's a cubic, there are going to be 3. Actually one of them is real and the other 2 are going to be complex conjugates of each other. And again, right click, and we could show the name and value for those. So you can actually see then, or the students can see, what the actual values are of those complex roots. And as the roots of the equation, in other words where it cuts the x-axis, come to the intercept, you can see that the complex component is actually 0.